Hello, everyone. Today, this is my presentation for the internship over the summer that we did with Ag Aid. So mine was predicting CAF success with machine learning. Just a little intro about myself. So I'm Nolan. I'm a computer scientist major at Syracuse University. And I also worked with Afef and Sinjhud Huja, which is in the Department of the Biological Systems Engineer, and also with John Wentz, who's Department of the Veterinary Medicine. And also just a shout out to Ag Aid for sponsoring me this whole summer. I had a great time, learned so much, and I'll show you what I learned with this presentation. So let's get going. Okay, so what is predicting CAF success with machine learning? Well, the image on the right, we can see a list of farms in bar graph form. And basically on the far right, we have a high mortality rate of almost 15% in calves. And all these farms use automated feeder systems. And this is a high mortality rate that we definitely want to lower down. So basically what our plan was is to predict success of calves at 5 months of age. Basically, a success calf is if they survive through their first lactation cycle. And a lactation cycle is basically when a cow gives birth to a calf, they start producing milk for around 10 months. And if the cow completes that cycle and survives it, that's a success. And we basically want to predict if it's going to succeed past the lactation cycle or if it's going to die somewhere along the way. So getting into our data set, at the beginning of the summer, we had an initial data set of over 56 calf-associated features. This was just a huge list of every single thing you could think of about the calf and its record. And it was just it was a lot. So basically, with the help of Dr. John Wentz, we narrowed these 56 features down to 16 key ones that we really wanted to pinpoint and keep and continue using with our machine learning methods that we'll get into the next slide. But yeah, basically these key features were breed, the birth season of the cow, the month, the illness record, the outcome of their first lactation, and some other less important variables. But basically with that, we also have on the left side the image of just pneumonia cases. And we can see on the top left, we just have the total of all of our data set, which is 95 that died, around 2,000 that dried or was a success, basically completing their 10-month lactation cycle, and then 300 that were sold, which is basically an off variable of them being sold somewhere along the way, and we can't really track what happened, so we just mark it as sold. So once we figured out our data set and narrowed it down to our key features, we actually got into the interesting stuff, I think at least, which was the actual machine learning part and 80-20 training test split, which I'll get into later. But kind of just stepping back and looking at the base methods that we use KNN, or K nearest neighbor, and random forest, both very popular machine learning methods, especially in this type of classification data. So basically for KNN, we have an overall accuracy of 85%. And what this algorithm does is basically classify all of our data that we put into training it. In this case, you could have class A as dried and class B as died. And you input data, this case being the red dot, and you would calculate the distance of the red dot to all the other points in class A and in point class B. And basically from that distance, calculating whatever it's closest to, you would classify it as that class. And also in our random forest, we had an overall accuracy of 82%. And this was basically how this works is you have a tree system of all the classes. And basically when you input data, it will go down the tree. And then at the end of all the different trees, it does a majority voting of which features it's most likely like, and then it just classifies it as that, for example. And going back to the 80-20 split, basically what this means is 80% of our data was just used training these models and basically getting them up to speed of what a died calf looks like, what a dried calf looks like, and et cetera. And then 20% is actually the training or the testing of this data. And this is where we get the overall accuracy and then our confusion matrix, which we will see in the next slide. And this is the confusion matrix I was talking about, also just very confusing in general, but I'll try to explain it the best I can. So basically, this matrix highlights our dominant class. As we said before with our data set, over 84% of our data set was dried or successful calves. So in our confusion matrix, we can see at the bottom, we have the predicted label, and then on the y-axis, our true label. So we see here for our dried class, we predicted 391 accurate predictions. And then for the dried, we predicted 14 that were sold and then 5 that died, which were incorrect predictions. So we can also see here, we had some errors. So for for example, our true label on the top column, we have died 0 that out of the, so the top column, there's 18 that died, the 15 and then the 3, but none of them were actually classified as died in our algorithm. And the reason for that is because of our dominant class dried, which was so overpowering the rest of our data set that most of these died or sold cows were just being classified as dried. And basically, for future research, definitely, the ways to fix this is to fix the imbalanced data, which is basically done by oversampling minority classes, the minority classes being our died and sold, or undersampling our majority classes, which is dried. So basically just evening the playing field for everyone and having the same number of each class, so nothing is overpowering. And then there we would see a much more stable prediction of most the died are going to be predicted died, most dried are going to be predicted dried, and maybe most sold are going to be predicted as sold. But sold is an off variable because they're sold at random times. But yeah, that's definitely just future research of basically furthering what I've done and making it a little more stable. And yeah, that's it. Thank you for listening. If you guys have any questions, I'm here in Zoom. So just let me know if you have anything. And thank you again for listening.